All right, so this video is for the portion of the test of equivalent forms. So if I give you one form, you are expected to either put it in factored form, vertex form, or standard form. So just a reminder, you will have to do all the problems, show all your work in order to participate in the retake. Okay? All right, so different sections for this. I'm just going to do a few from each section, then the expectation is you do the rest. So the first 6 are asking me to go into factored form. So these are all standard form, and the clue is factored form. So that means I will be factoring these. So we just recently made that green page, but the first step in all factoring is finding a GCF. So in my first problem, when I'm looking at this 12x squared, 12x, and 9, I can actually take a 3 out, and I do expect you guys to be factoring the GCF out. So I'm going to take a 3 out, and then I'm left with 4x squared, 4x minus 3. So at this point, I have a GCF, and now this is what I'm trying to factor. So with 3 terms, we make our x, and I fill out the x by multiplying these for negative 12x squared, and circle the middle one. And now I need factors of negative 12. That will get me to 4, and that will be 6 and 2. With x's, and I'm going to make the 2 negative so I can get to the 4x. So at this point, what I'm going to do is I'm going to rewrite this problem, this 4x squared plus 4x minus 3. And instead of 4x looking like this, I'm going to have this version of 4x. So 4x squared plus 6x minus 2x minus 3. And now with the 4, what I'm going to do is group them, the first 2 and the last 2. And I start with a GCF in my first set of parentheses. So in this, I can factor out a 2 and an x. And when I do that, I'm left with a 2x and a 3. And that means when I go to factor my GCF on the second set, these will match. So I'll have another 2x plus 3. And that means I factored out a negative 1. And so now I have my factors in front of me. One set is the 2x minus 1. The other is the 2x plus 3, and then I do not want to forget about my GCF of 3. So this is my final answer for number 1. All right, let's go to the one below it. So the first thing I'm going to do is look for a GCF. You might not think there is one, but it is much easier to factor if this leading term is positive. So I'm actually going to factor out a negative 1. And now this is what I'm going to try to factor. So I'll make my x. So I do this loop, and I'll need factors of 24 that get me to 11. And I can run my factor program, but I'm going to learn that they are 8 and 3. And now, again, I'm going to rewrite this problem. But instead of 11x looking like this, I'm going to have 11x look like this. So this is the problem that I'm going to rewrite. So 4x squared, 8x, 3x, and 6. And again, with the 4, I wrap them in parentheses, the first 2 and the last 2. And I look for a GCF here. And I can take a 4 and an x out. And so 4x times what gives me the 4x squared? That's an x. 4x times what gives me 8x? That's a 2. So when I go to GCF the second set of parentheses, remember I'll have the match. And so I have to ask what times x gives me the 3x, and that's a 3. And now joining my GCF of negative 1 is the x plus 2. And then again, those things that are outside of the parentheses, the 4x plus 3. All right, so at this point, as you go through these problems, 2 and 4 are very similar. So pause the video and move into problem 2 and 4. All right, the next set I'm going to cover on these 4 are actually easy factoring because as you notice in 5, 6, and 7, I don't have a number joining the n squared or the n squared or the x squared. So I can, first there's not going to be GCF, something that I can take out of all 3 of these. So I'm going to make my x. What are factors of negative 20 that get me to 8? And if you really like this method that I showed you at the top, my factors are going to be 10 and -2. You can rewrite this. So instead of 8n looking like this, 8n will look like this. So I'll rewrite it, n squared. Here comes my 8n. And you can group them and get your answer. But if this is easy factoring, which this is because it's just n squared, you actually have the parts of your factor. It's going to be n plus 10 and n minus 2. So 5 is factored. 6 and 7, very similar, and even 8 is going to be similar, because if you take a look at 8 and you actually notice there's a GCF of 5, then when you take the 5 out and you're left with n squared minus 7n plus 6, you now have easy factoring. And what some of you are struggling with is the x part. So remember, I need numbers that multiply to give me this, but add to give me this. So your numbers on the sides aren't just some random factors. There's a purpose of why you pick the set that you pick. All right, that is the factoring portion. So again, you can either pause and finish those problems, which is what I recommend to do. The last part of the factoring, these are known as the difference of squares, but I'm still going to approach the problems looking for a GCF. So I'm going to do, for instance, number 9, and the first thing I always do in factoring is I look for a GCF, and this doesn't have one. But the big difference between these 4 problems and the other problems is there are only 2 terms, and it's called a difference of squares because there is subtraction, and these are perfect squares, which means they have nice square roots. The square root of 4n squared is 2n, and the square root of 9 is 3. And with that, I've got my factors. The 2n and 3 fill both fractions. So different things that I've seen, this will not be correct. I've seen n plus 2n and n plus 3, and that's not right. Your factors are going to be 2n plus 3 and 2n minus 3, and now this has been factored. When you go to 10, again, look for a GCF, and this one actually does have a GCF. I can take a 3 out. After I take that 3 out, I have a squared minus 16. And with these 2 terms, there is subtraction, and these are perfect squares. The square root of a squared is a, the square root of 16 is 4, and now joining my GCF of 3 will be an a plus 4 and an a minus 4. And this one is done. All right, so you'll try 11 and 12, and these are the problems that are going from standard form to factored form. I factor, and again, I always start with the GCF, and then I wait to see if it's 2 terms or 3 terms.